What if I told you our calm and serene moon had a violent origin?
The Moon, Earth's closest celestial neighbor, has been a target for countless space missions, some with explosive outcomes.
Well, it vibrated, so it was kind of an early clue as to how solid was the surface of the moon.
From mysterious impacts to NASA's intentional crash landings, the Moon has seen its fair share of dramatic collisions, revealing surprising secrets about its surface and history. Moon crash that puzzled the scientists. The Moon, our quiet neighbor in the sky, has been hit by countless objects over billions of years. But last night, something unexpected happened. A bright flash lit up the Moon's surface, catching the attention of astronomers worldwide. At first, it seemed like another meteoroid strike, but it was much more interesting. Telescopes worldwide spotted a sudden burst of light on the Moon. These flashes, called transient lunar phenomena, are usually caused by meteoroids, small space rocks, that crash into the Moon at high speeds. These rocks slam into the surface without an atmosphere to slow them down and create brief, bright flashes. But this time, scientists quickly realized this wasn't an ordinary rock. After studying the data, experts believe the object that hit the Moon was artificial, likely a piece of space debris. Space debris includes leftover parts from satellites, rocket stages, or fragments of old missions. With thousands of these objects floating around Earth, it's not unusual for some to drift off and end up on the Moon. What made this impact special was the size and speed of the debris, which caused a bigger, brighter flash than usual. Unlike natural space rocks, human-made debris tells a different story. It highlights our growing activity in space and the mess we've left behind. The Moon has no protection from these objects, and every hit somehow changes its surface. This event raises important questions. How much debris are we leaving in space? What happens when it travels beyond Earth? This unexpected strike is a wake-up call for scientists, space agencies, and private companies. As more countries and businesses explore space, and even plan to live on the Moon, we need to think about the impact of our actions. Leaving too much debris in space could lead to serious problems, not just for Earth, but for other celestial bodies as well. Scientists are now studying the impact site to learn more about the object. They hope to determine where it came from and what it was made of. At the same time, this incident has sparked fresh discussions about space debris. Experts call for stricter rules to manage the waste we create in space. Space might feel far away, but what happens up there affects us all. This bright flash on the Moon is more than just a cool sight. It's a reminder of how our actions reach beyond Earth. If we want to keep exploring and protecting the wonders of space, we need to clean up after ourselves, even in the great unknown. You're enjoying this video, right? If so, please take a moment to like and subscribe to the channel so you won't miss any amazing content in the future. NASA detected blinking lights on the Moon. The Moon has always fascinated us, but our closest space neighbor still has secrets to share. Scientists and astronomers have observed strange flashing lights on its surface for centuries, and no one knows exactly what causes them. These mysterious lights have sparked countless theories, ranging from meteorite impacts to unknown phenomena. Some even wonder if they could be signals from alien life. Known as transient lunar phenomena, or TLP, these flashes were officially named in 1958. However, sightings go back much further. In 1787, famed astronomer William Herschel reported reddish glowing spots on the Moon, which he thought might be erupting volcanoes. Over the years, people have described these lights in various colors, including red, blue, orange, and violet. Most flashes last just a second or two, but some have been known to linger for minutes or even hours. The lights are also surprisingly large, ranging from a few miles wide to hundreds of miles across. While these events happen all over the Moon, they appear more frequently in certain areas, like the Aristarchus crater. Scientists say they're not rare. Flashes have been detected multiple times a week. Despite centuries of observation, their exact cause remains unclear, but experts have a few theories. One possibility is meteorite impacts. Without an atmosphere to protect it, space rocks constantly bombard the Moon, and these impacts can create brief but bright flashes of light. Another theory involves lunar outgassing, which occurs when gases trapped inside the Moon escape through cracks in the surface. These gases could reflect sunlight and create glowing spots. Some scientists believe solar wind plays a role. Charged particles from the sun interacting with moon dust could generate brief electrical flashes. Others suggest seismic activity, like moonquakes, could trigger these events by shifting the surface or releasing trapped gases. Of course, there are always more speculative ideas, such as unidentified flying objects or other unknown phenomena, though no evidence supports these claims. Researchers have turned to advanced technology to study these lights in greater detail. A telescope in Spain, located northeast of Seville, monitors the moon every night using 2 cameras. When a flash is detected, the telescope records pictures and videos, which are then analyzed by a team of scientists. Professor Håkan Kyle led the researchers to compare their findings with data from other observatories to confirm whether the same event was observed elsewhere. The team is also improving the telescope's software to filter out false alarms caused by planes, birds, or other Earth-based distractions. This work is important for understanding the transient lunar phenomenon and developing technology that could be used on future missions to other planets. These lights are more than a fascinating mystery. They could have practical implications. Understanding these events is crucial as nations and private companies prepare for human missions and potential colonies on the moon. If a transient lunar phenomenon is caused by impacts or seismic activity, it could pose risks to astronauts and equipment. Studying these flashes might help us learn more about the moon's history and inner workings. For now, the mystery continues. But with new tools and renewed interest in lunar exploration, answers may not be far away. James Webb Telescope discovers. Huge structure on the dark side of the moon. The James Webb Telescope has been blowing our minds with discoveries across the cosmos, but now it's helping us learn more about something much closer to home, the moon. Specifically, the far side of the moon, the side we never see from Earth. This mysterious dark isn't dark. It gets just as much sunlight as the nearby side, but because it always faces away from us, it has remained hidden and largely unexplored. For years, scientists have been trying to understand why the far side differs from the side we know. Unlike the near side, which is smooth in some areas, the far side is covered in craters, and no one's sure why. One theory suggests a massive event in the moon's past caused this difference. Thanks to advanced technology like the James Webb Telescope and various space missions, we're starting to uncover some of these secrets. China's Chang'e 4 mission made history in 2019 by landing a rover on the far side of the moon. This rover, called Yutu-2, discovered some fascinating things, like a strange translucent glass-like material. These glass spheres are bigger than usual and have a unique brownish color, making scientists wonder if they form naturally or have a more mysterious origin. There's also a lot of buzz about lunar swirls, light-colored patterns that only appear on the near side of the moon, and unusual noises recorded during the Apollo 10 mission in 1969. Astronauts described hearing a whistling sound while flying over the far side, which NASA later called radio interference. However, some conspiracy theorists believe it could hint at extraterrestrial activity. Speaking of mysteries, there are also rumors about secret moon bases. In the 1960s, the US considered building a base called Project Horizon to store nuclear missiles on the moon. Although officially canceled, some wonder if such a base was secretly built, hidden on the far side where no one can see. NASA isn't just solving mysteries. It's planning for the future. The upcoming Artemis program aims to send humans back to the moon and build a sustainable presence there. NASA is also working on projects like the Lunar Crater Radio Telescope, which would turn a crater on the far side into a giant observatory. This telescope could capture faint signals from the early universe by avoiding Earth's radio interference, helping scientists learn more about how galaxies formed billions of years ago. The moon's far side offers many possibilities, from studying its geology to searching for water ice in permanently shadowed regions. Missions like these could pave the way for long-term lunar exploration and even help us prepare for Mars missions in the future. The more we explore, the more we realize the moon isn't just a lifeless rock. It's a treasure trove of secrets waiting to be uncovered. Will we find proof of extraterrestrial life? Or will we unlock new scientific discoveries? One thing's for sure, the moon's dark side isn't as silent as we once thought. The Moon is Not What You Think by Michio Kaku. The moon has always been a source of wonder and mystery. For years, we believed we understood its origins, purpose, and composition. But recent discoveries challenge everything we thought we knew. Renowned physicist Michio Kaku reveals surprising insights that could reshape our understanding of the moon. China has made incredible strides in lunar exploration, becoming the third country to collect samples from the moon. Using advanced technology, their Chang'e 5 mission found something fascinating: tiny glass beads containing water. This water discovery, published in Nature Geoscience, could be a game changer for future space missions. For years, scientists thought water only existed in the moon's shadowed craters, but new findings show water even in sunlit areas. Lunar water isn't the only exciting discovery. A new mineral, changesite, Y, found by Chinese scientists, contains helium-3, a rare element that could power nuclear fusion for clean energy. Just 25 tons of helium-3 could power the US for a year. However, mining it from the moon would be expensive and challenging. Beyond resources, the moon offers clues about the past. The South Pole Aitken Basin, the largest known crater, is a prime target for exploration. Its unique composition might reveal secrets about the moon's formation and even Earth's history. Recent research uncovered a massive structure beneath this basin, possibly from an ancient asteroid impact. The moon's core has also been a focus of study. NASA's Grail mission revealed that the moon's inner core is solid and similar to iron, surrounded by a liquid layer. This discovery helps scientists understand how the moon and other celestial bodies formed. Private companies are also pushing boundaries. Elon Musk dreams of human colonies on other planets, while Jeff Bezos envisions moving heavy industries into space. Their efforts fuel innovation and bring us closer to making space exploration a reality for everyone. Space is no longer just about competition between nations. It's about advancing science, protecting our planet, and finding new ways to live and work beyond Earth. The moon, once considered barren, is full of surprises that could shape humanity's future. As we uncover more lunar mysteries, one thing is clear: our closest neighbor in space still has plenty to teach us. Giant impact theory. The moon has always fascinated us. Long before we understood that planets shared the solar system with Earth, we knew the moon was special. One of the first big questions people wondered was, how did the moon come to be? 50 years ago, humans set foot on the moon, an incredible achievement for science and exploration. The Apollo program brought back nearly 900 pounds, 400 kilograms of lunar rocks, giving us clues to solve the mystery of the moon's origin. The moon holds secrets Earth has lost. While Earth's surface constantly changes due to weather and geological activity, the moon's surface has remained mostly the same for billions of years. Studying it is like looking back in time. Before Apollo, scientists had three main ideas about how the moon formed. One idea was that the moon formed elsewhere and was caught by Earth's gravity. Another theory suggested the moon and Earth formed together from the same material. A third idea imagined Earth spinning so fast that part of it broke off to create the moon. Apollo samples helped rule out these theories. For example, the rocks revealed the moon formed about 4.5 billion years ago, around the same time as Earth. They also showed the moon has very little iron compared to Earth. Yet, the moon's rocks and Earth's mantle have similar oxygen levels, proving a shared history. The moon's rocks also lack elements that evaporate in heat, hinting it formed during a fiery event. In the 1970s, scientists proposed a new idea: the giant impact hypothesis. They suggested a Mars-sized planet, later called Theia, collided with Earth, throwing debris into orbit. This debris eventually formed the moon. The theory explained the moon's lack of iron, its shared history with Earth, and why it formed so close to our planet. At first, many scientists doubted this idea. However, as they dug deeper, other theories fell apart, and the impact hypothesis became the strongest explanation. New computer simulations, though hard to create then, showed how a massive collision could form the moon. Today, we believe the moon's origin story is one of cosmic violence, yet it brought us the closest companion in the night sky. LCROSS mission in 2009. National Aeronautics and Space Administration's Lunar Crater Observation and Sensing Satellite, LCROSS, was designed to determine whether water ice exists in a permanently shadowed crater near the moon's south pole. It launched in 2009 and traveled with another spacecraft, the Lunar Reconnaissance Orbiter, LRO, as part of a program to prepare for future moon missions. Lunar Crater Observation and Sensing Satellite had a bold plan. It carried a large rocket stage called Centaur, which it sent crashing into the moon's Cabeus crater on October 9, 2009. This impact created a massive debris plume, shooting up material likely hidden from sunlight for billions of years. Lunar Crater Observation and Sensing Satellite flew through the plume 4 minutes later, collecting data before crashing into the moon shortly after. What did scientists find? They confirmed that the moon has water, specifically ice. Some of the water exists as nearly pure ice crystals, while other materials in the soil suggest the moon is chemically active and even has a water cycle. The crater's soil also contained valuable materials like mercury, magnesium, calcium, and silver. The mission was challenging. In August 2009, the Lunar Crater Observation and Sensing Satellite lost over half its fuel due to a sensor problem. Despite this setback, the team adjusted the mission and still succeeded in meeting its goals, though with less room for error. Lunar Crater Observation and Sensing Satellite and Centaur worked together in a fascinating sequence. After separating from the Lunar Reconnaissance Orbiter, the pair entered a special orbit that allowed them to pass the moon multiple times while preparing for the big impact. On the final pass, Centaur slammed into the moon at 5,600 miles per hour, carving a crater about 66 feet, 20 meters wide, and ejecting about 350 metric tons of lunar material. Following the impacts, the Lunar Reconnaissance Orbiter passed over the site, capturing infrared images of the debris. A month later, in November 2009, the National Aeronautics and Space Administration officially announced that the Lunar Crater Observation and Sensing Satellite had discovered water at the moon's south pole. A year after the mission, scientists shared even more findings. They confirmed that the moon's south pole has areas rich in resources, and the discovery of water ice sparked new ideas for future lunar exploration. Lunar Crater Observation and Sensing Satellite showed us that the moon isn't just a dry, dusty place full of potential. Space rock hits. Moon results in bright explosion. National Aeronautics and Space Administration, however, on March 17, 2013, something extraordinary happened. The biggest explosion the National Aeronautics and Space Administration had ever seen occurred when a rock about the size of a small boulder slammed into the moon. This rock traveled at an incredible speed of 56,000 miles per hour and hit the moon in the Mare Imbrium region. The impact was so powerful that it caused a flash brighter than anything the National Aeronautics and Space Administration had ever witnessed, nearly 10 times as bright as the usual impacts. For about a second, the impact site shone as brightly as a fourth magnitude star, which is visible to the naked eye. It was so bright that anyone looking at the moon could have seen the explosion without a telescope. The rock, which weighed about 40 kilograms, around 88 pounds, exploded with the force of 5 tons of TNT. National Aeronautics and Space Administration. Scientists, including Bill Cook from the Meteoroid Environment Office, believe this impact was part of a larger event. On the same night, scientists at the University of Western Ontario and the National Aeronautics and Space Administration's all-sky cameras detected several other meteoroids entering Earth's atmosphere. These meteoroids traveled in similar orbits, which suggests that the Earth and Moon were both hit by meteoroids at almost the same time. This event sparked a lot of interest because the National Aeronautics and Space Administration is always looking for new streams of space debris that could threaten Earth and the Moon. After the impact, the National Aeronautics and Space Administration's Lunar Reconnaissance Orbiter, LRO, was informed about the strike. The impact site could have left a crater as wide as 20 meters, which would make it easy for the Lunar Reconnaissance Orbiter to examine when it passed over the area. Since 2005, the National Aeronautics and Space Administration's Lunar Impact Monitoring Program has detected over 300 smaller lunar strikes. While most meteoroids come from known sources like the Perseids and Leonids meteor showers, others come from unknown debris. Understanding these impacts is crucial, especially as the National Aeronautics and Space Administration plans for future astronauts to spend more time on the moon. Knowing what kind of space rocks could strike the moon helps the National Aeronautics and Space Administration prepare for those missions. NASA's DART mission to an asteroid. National Aeronautics and Space Administration's DART mission, or Double Asteroid Redirection Test, was the first to detect Earth from potential asteroid impacts. Double Asteroid Redirection Test tried to change an asteroid's path by crashing into it at high speed, testing a technique called kinetic impact. The total cost of the Double Asteroid Redirection Test mission was $324.5 million. This included $308 million for developing the spacecraft, $68.8 million for the launch, and $16.5 million for operations and data analysis. The Double Asteroid Redirection Test spacecraft was relatively small, about a meter wide, but its solar panels stretched to around 12 meters, 40 feet, across. It used an electric propulsion system system to gently push itself through space by releasing charged ions. Double Asteroid Redirection Test launched in November 2021 aboard a SpaceX Falcon 9 rocket from California and traveled around Earth several times, gaining speed before heading toward its target, Didymos, a binary asteroid system. Along the way, it passed another asteroid called 2001 CB21. The spacecraft's main science instrument was a high-resolution camera called Draco, which helped navigate and capture detailed images. In September 2022, the Double Asteroid Redirection Test released a small Italian-made CubeSat called Light Italian CubeSat for imaging of asteroids to observe the impact. Because the spacecraft was too far from Earth to control in real time, it used onboard software called SmartNav to guide itself toward its target, Dimorphos, one of the 2 asteroids in the Didymos system. On September 26, 2022, the Double Asteroid Redirection Test slammed into Dimorphos at 6.6 kilometers, 4.1 miles per second. The goal was to shift Dimorphos' orbit by just a few minutes, but the actual effect was even more dramatic. The asteroid's orbit changed by 33 minutes, much more than expected. Double Asteroid Redirection Test's mission team celebrated Double Asteroid Redirection Test's success with support from telescopes like Hubble and James Webb and ground observatories. Double Asteroid Redirection Test is part of a joint project with the European Space Agency, ESA, called IDA, which includes ESA's Hera mission. Hera will visit Dimorphos after the impact to study how the collision changed its orbit and surface. National Aeronautics and Space Administration's Planetary Defense Coordination Office funded the Double Asteroid Redirection Test, and the Johns Hopkins Applied Physics Laboratory managed the mission and oversaw the science. Apollo 12 uncovers a hollow moon. The idea that the moon is hollow might sound strange today, but it was once taken seriously. It all started during the 1969 Apollo missions, especially Apollo 12. National Aeronautics and Space Administration wanted to learn more about the moon's composition, so astronauts Pete Conrad and Alan Bean set up a seismometer on the lunar surface. This device recorded moonquakes vibrations caused by natural and human-made events. After the astronauts left, they deliberately crashed the lunar module into the moon, creating the first human-made moonquake. The result was unexpected. The seismic waves from the crash lasted much longer than scientists anticipated. Earth's earthquake vibrations typically last a minute or two, but the moon's vibrations continue for much longer. Some of them lasted up to an hour. National Aeronautics and Space Administration scientists said the moon rang like a bell, a term that sparked the hollow moon theory. The idea was that the vibrations could only happen if there were vast empty spaces inside the moon for the sound waves to bounce around. However, scientists later explained that the moon's structure differs from Earth's. The moon is dry and lacks the water that absorbs seismic energy on Earth. Because of this, the moon's surface is much stiffer, allowing the vibrations to last longer. So, while it might have sounded like a bell ringing, it wasn't because the moon is hollow. Despite the scientific explanation, conspiracy theorists still believed the moon was hollow, despite no real evidence supporting it. Over time, as NASA continued to study moonquakes during the Apollo 13, 14, 15, and 16 missions, scientists gathered more information about the moon's composition, ruling out the hollow theory. The moon is less dense than Earth, but that doesn't mean it's empty inside. Today, scientists continue to study the moon's interior. NASA's upcoming subsurface lunar investigation and monitoring experiment, SUBLIME, will help map the moon's core and learn more about moonquakes. Although the hollow moon idea has been debunked, there's still much to discover about our lunar neighbor. The Apollo 13 Booster Impact Experiment. Apollo 13, launched on April 11, 1970, was a mission that quickly turned from routine to life-threatening. The spacecraft, carrying astronauts Jim Lovell, Fred Hayes, and Jack Swigert, left Earth and began its journey to the moon. Things were going smoothly until, 2 days into the mission, a loud bang echoed through the spacecraft. This explosion was caused by a damaged oxygen tank, which had been improperly repaired before the mission. The tank ruptured, leaking gas into space and damaging other spacecraft parts. The crew quickly decided they wouldn't land on the moon as planned. The damage to the spacecraft meant they were in danger of losing power and oxygen. Lovell, Hayes, and Swigert moved to the lunar module, which became their lifeboat. The lunar module was designed to land on the moon, but instead, it had to help the astronauts survive and find a way back to Earth. Mission Control in Houston responded fast, shifting the mission's focus from landing on the moon to getting the astronauts home safely. The spacecraft's power was dwindling, and the crew had to make quick decisions. They used the lunar module's engine to adjust their course so they could fly around the moon and return to Earth. The mission's original goal had to be abandoned. Instead, they had to work together to survive and deal with the ongoing crisis. Despite the overwhelming challenges, teamwork and problem-solving became the mission's focus. Engineers and astronauts worked together, often in high-pressure situations, to find solutions. They communicated constantly, using backup systems and tools to monitor the spacecraft's condition. One of the most difficult tasks was transferring important navigation data from the damage command to the lunar module. Ultimately, thanks to quick thinking, solid training, and a calm approach, Apollo 13's crew returned safely. Though not successful in landing on the moon, the mission became a textbook example of how to handle a crisis in space. The teamwork and leadership displayed during the mission saved the astronauts' lives, proving the importance of preparation and unity in overcoming adversity. In the vastness of space, the moon remains a silent witness to the unexpected, from cosmic impacts to human-made debris. National Aeronautics and Space Administration's deliberate lunar crashes remind us of our ongoing exploration, leaving behind traces of curiosity and ambition. As we look to the future, these events urge us to consider the lasting effects of our presence beyond Earth's atmosphere.